Welcome to video number 34 in the Using iTrain tutorial series. My name is Bob. This is part one of a two-part tutorial in which we will be exploring the use of optimal length block selection within a station. In this part one, we will look at how iTrain selects a block using optimal length. In part two, we look at how to set up a block to cope with variations in actual stopping positions and for stopping aligned along a platform. Welcome back. The next station block selection method that we will look at is optimal length. Optimal length means all the blocks in the list here are sorted in the order of their length from shortest to longest blocks. Blocks that are too short for the selected train are removed from the list of available blocks. Then the first block in the resorted list of blocks will be chosen unless it is already occupied. Then the next block will be tried, and so on. We don't get to see the new resorted list of blocks. That's held internally by iTrain. So the order shown here will be ignored when we're using optimal length. The optimal length option is used to prevent short trains from occupying a long block in a station and therefore preventing a longer train from entering the station because only shorter blocks remain available. So, for example, it could be used in a yard to optimize capacity because the block lengths are more efficiently utilized. Or it could be used in a passenger station to help ensure the optimal use of the platforms based on their length. iTrain calculates the room available in a block by subtracting the block margin from the block length. And the result of that calculation is the usable length of the block. If we open the properties of a block, like this one for example, by right-clicking on it and clicking on the properties, we see the margin figure up here. It's greyed out at the moment, but you can just see it's saying 5.7 centimeters. This figure varies depending on the block type and the layout scale. As we can see here, for a 00 gauge layout, which is 1/76 scale in the UK scale, the margin figure for a station block is 5.7 centimeters. If we change the type to a free track, the margin figure increases to 11.4 centimeters because of the increased speed of the trains expected on a free track block versus a station block or a shunting block. If you remember, margin is the extra space allotted in a block to allow for differences in the stopping positions of different trains. When we create a block, iTrain automatically fills in the default value here. We can override the default value by clicking on the margin box here and then entering our own margin figure. We will see later why you might want to change this margin value. If we untick it to take it back to its default, we can then have a look at the default settings for other block types. So for a shunt it is 5.7 centimeters. For a siding it is 5.7 centimeters. And for a turntable, for example, it is 3.4 centimeters. If we close the block properties down and then go to the edit menu and settings, if I change the scale here to, for example, N gauge, UK N gauge, which is 1/148 scale, if we change that and then look at the block properties again, we see that for a station the default value has changed to 2.9 centimeters, and for a free track it is 5.9 centimeters. So you can see that that margin value does vary depending on the type of block and on the scale of your layout. Let me just take it back to 00 scale again and click OK. In our layout example here, we have block 1 set up as a 70 centimeter long block. It's using a station block and we are in 00/176 scale, so the margin is 5.7 centimeters. So the usable length of the block is 70 minus 5.7, which is 64.3 centimeters. Block 2 is a station block as well. It has a block length of 60 centimeters minus the margin of 5.7 equals a usable length of the block of 54.3 centimeters. And block 3 is a 50 centimeter block minus 5.7 gives a usable length of 44.3 centimeters. For this layout, I've constructed 4 trains. Here are their names, and here are the lengths of each of those trains. In the station properties, we have already set the selection to optimal length. The block list here shows the order of the blocks and the blocks that are assigned here. But with optimal length selected, the block order shown here is ignored, and internally iTrain will have reordered the blocks according to their usable block length, starting from the shortest block to the longest block. So in our example here, the block order would be B3, B2 and then B1. When we set a train onto the layout and put it into automatic routing without a route, iTrain will test the length of the train that we have selected against the usable length of the blocks in the station. Any blocks that are shorter than the length of the train that we have selected will be removed from the list of available blocks. Again, we won't see it being removed from the list of blocks shown here. That all happens internally in the background. Let's try some examples. We'll place the shortest train, which is DBIC, onto the layout. DBIC has a length of 43.3 centimeters, so it is able to fit into any of the blocks here. So all of the blocks are available for DBIC to use. But because it is the shortest train, we want it to use the shortest block, which is block 3. Let's see if it does. We've got no route selected down here, so we know when we press the start button we will be in automatic routing without a route. So I click the start button and yes, it correctly chooses block 3 for us. And if I stop and start the route, we can see if it consistently chooses that block. And it does. And we can see that the block is a solid orange colour, showing that it will be expecting to wait in that block, and therefore we know that that selection process is active, like we saw with other selection types. And if we simulate block 3 being occupied by alt clicking on the block, we then see that when we start the automatic route, it chooses the next longest block. Okay, so let's reset that and let's see what happens when we use DB car. DB car is a slightly longer train. It has a length of 54.3 centimeters. That makes it too long to fit into block 3, and it is exactly the same length as the usable length of block 2. So let's see what happens when we use this train. We'll re-enable block 3 and then press the start. And you can see that it has chosen block 2. It uses block 2 because it is too long for block 3. So block 3 would have been removed from the list of available blocks. And the train is just short enough to be able to use block 2. So block 2 was selected. Let's see what happens when we use DB pole this time. So we'll remove DB car and we'll put DB pole into this throttle, place it onto the layout. DB pole has a length of 54.4 centimeters, so it is only 0.1 of a centimeter longer than block 2. So what do you think will happen? We'll click the start button and sure enough it goes into block 1. Now what happens in this situation if block 1 is occupied? Let's alt click on it. What do you think will happen this time? Let's press the play button and see. What happens is that iTrain patiently waits outside the station until that block becomes available. And if I alt click on it again, you see when it becomes available, iTrain is then able to move the train into the block. Okay, so far so good. Now let's see what happens with the class 33 train here. I'll move that onto this throttle. It has a length of 66.4 centimeters, which is 0.1 of a centimeter longer than the longest block in our station. So what do you think will happen this time? Again, iTrain will test the length of this train against the length of each of the blocks to see if their usable length is long enough to accept the train. Any blocks that are shorter than the length of the train will be removed. Let's remove DB pole from this layout and place the class 33 onto the layout, and look what happens when we press the start button. We get a message down here saying route not possible from this position. iTrain is unable to start this automatic route because there are no blocks available in the route that is long enough to accept the train. Now, look what happens when we do this. Let's open the station properties, and in the blocks tab we see a column called length, and there's a tick against each of the blocks in this station here. This tick tells iTrain to test for the length of the train entering that particular block. Let's untick the test for block 1 and then press OK to save it. We'll double click on this error down here to remove the error, and then we'll press the start button. This time iTrain allows the train to enter block 1 because it's not testing for the length of the train, and the train can therefore enter the block. So unticking that length checkbox allows a train that is longer than the usable length of the block to enter the block. We'll be looking at what all of these ticks and columns in the blocks tab mean in a future video. So we'll leave it there and just retick this box. So that is all for this tutorial. We saw how optimal length can be used so that trains are allocated to the most appropriate block based on their length, allowing for more efficient use of the blocks. We showed that usable block length is equal to the total block length minus the margin, and iTrain uses usable block length to test if a block is long enough to accept a train. We showed examples of different lengths of trains being selected for different lengths of block. and we saw what happens when a train is too long to enter any of the blocks. And we showed that the length test can be turned on and off per block using the length checkbox in the station properties. In the next tutorial, which is part 2, we look at how to set up a block to cope with variations in the actual stopping positions of our trains and how to align a train along a platform. Hope to see you then. Thanks for watching.